So Tuesday of next week, we're going to have another formative. Okay? Yesterday you got back this week's formative. If you have those corrections, make sure you turn those into the basket at some point in time. If you fixed your homeworks that you got back yesterday also and want to get those turned in, that would be great too. So next week, Tuesday, we're going to have a formative, and then a week from today, next week, Friday, we're going to have the test on unit test. Remember, for the test, you can have your note packet, and you can utilize that too. Okay? All right? So what I would like you to do now is I would like you to start with the two warm-up problems on F7, and that would be these two right here. Start by doing those right now. So in the warm-up here, just like we were doing yesterday, we've got an expression, an algebraic expression. In this case, it's 4x plus 1. And we're going to replace the x with a number. In this particular case, it's 0. So we're going to substitute in 0 for x. 4 times 0 is going to be 0. 0 plus 1 is going to be 1. So when we evaluate this expression at x equals 0, we get just 1. Over here on this one, same thing. We've got an expression. It's 3 halves times x plus 1, and we're going to evaluate that when x is negative 6. So we're going to plug in negative 6 into that expression on this equation. So then we've got 3 over 2 times negative 6 over 1. If I multiply straight across, I get negative 18 over 2. Still adding 1, still coming along for the ride. Negative 18 divided by 2 is negative 9. Still adding 1, negative 9 plus 1 is negative 8. So we should have negative 8 for that one right there. Okay. Good. All right. Let's do the first example, kind of like what we did yesterday. Okay. So we don't have a line that's graphed, so we can't just plot our points and determine if that point is on the line because there's no line there to do that. So we have to algebraically show that if this point is on the line or if it isn't on the line. So here is the equation of our suspected line. We're then going to say that x is going to be 2 and y is going to be 3. And so what we're going to do then is we're going to plug those values back into our equation. Negative 3 is going to equal negative 2 times 2 plus 1. Working the right side. Negative 2 times positive 2 is negative 4. Negative 4 plus 1 is negative 3, and negative 3 is equal to negative 3. So is this point on the line? Yeah, this point is on the line, which means that we can then plot that point because it's going to be on the line that we are about to draw. How would I go about plotting point A on my grid? The point is 2, negative 3. How would I plot that on my grid? Write 2 down 3. Write 2, 1 and 2, down 3, 1 and 2 and 3. Put a big old dot right there. Okay. So there it is. And then we gotta label it. Oops, because this has got a label. Point A. Got ahead of myself there. Okay. B, then, Now my x is negative 3. My y is negative 7. My y was negative 7. My x was negative 3. Negative 2 times negative 3. Positive 6. Yep. Positive 6 plus 1. Positive 7. Is positive 7 equal to negative 7? Nope, not equal. So therefore, this point is not on the line. So I don't have to graph it. Then we go on to point C. Y equals negative 2x plus 1. Negative 2 times negative 1. 2. 2 plus 1. 3. Is 3 equal to 3? Yeah, so that point is on the line now. How do I get to point C? Negative 1, comma 3. Left 1 and up 3. Point C. Left 1, up 3 is point C. Now, we learned yesterday that how many points does it take to make a line? 2. So we could draw in our line right now. This is where that having that ID, a ruler, or something straight like the edge of your folder comes in, because we want to draw in straight lines now. Okay? So we want to use that to draw in a straight line, and we're going to have that straight line go all of the way across our graph so that the arrowheads on the straight line are outside of the graph. Okay, so we want our arrowheads outside of the graph. Come on, why are you doing that to me? Twice today. Where we're getting to with this, the reason I'm making you use something straight is because we're going to be graphing next unit multiple lines on the same grid. And so you need to have those all be perfect so that you can find the intersection points of them. Okay? So we're going all the way across our grid. Now that we have our line graph, we can figure out if point D is on the line by plotting it, or we can solve it by algebra. Okay? So if I plot the point 0, 1, that's going to be left and right 0, but up 1, that's going to be that point right there, which is on our line. So this is going to be a yes. Algebraically, let's prove this one. So we're going to have y equals negative x plus 1, or negative 2x plus 1. My x value is going to be 0. My y value is going to be 1. negative 2 times 0 is 0, plus 1 is 1, and 1 is equal to 1. So it's on the line. Find me, now in part E, find me another point that is on the line. Okay. Graphically, positive 1, negative 1 would be right 1, down 1. That would be my point E right there. Algebraically, it would need to fit into this equation. Negative 2 times positive 1 is negative 2. Negative 2 plus 1 is negative 1. And negative 1 is equal to negative 1. Okay? Part F says make a table of values for this line. Well, I'm going to start with that one that we just had. That would be the point 1 comma negative 1 has an x value of 1 and a y value of negative 1. Okay? So that point is on the line, so it can go in our chart that we made for this one. We also had two other points. We had point C, negative 1 comma 3 would go in the chart as a negative 1 in the left column and a 3 in the right column. We also had point D, 0 comma 1, that would go in as a 0 in the x column, 1 in the y column. We had point A, 2 comma negative 3, go in there. That one works out as well. We just have to fill in 2 more lines in our chart. Well, we can go back to our graph and we can say we need 2 more points that are on the line. Here's one, there's one. Got all those, there's one, and there's one right there. It's being so sensitive. What do you got? So how would that go in my chart? What would my x value be? Negative 3. What would my y value be? Give me another one. 3 comma negative 5. So we have a 3 and a negative 5. Right? Okay. And then we filled in our chart. Okay. So backside here now, number 2. Now we're going to switch it up a little bit. So now we're just going to give you a table. We're not going to say plot these points. We're going to give you a table of values. And then we're going to give you a third column in that table. And that's going to be where you show if that point is on that line or not. So for all of these points in this table, they're going off of this line right here. Negative 2x plus 1. Okay? So if I wanted to prove that 0 for x and 1 for y was on my line, I would think about this in my table. It's 0 in one column, 1 in the other, but in my brain, what I'm thinking about is this is really representing the point 0, 1. Okay? So I'm going to put in 0 for x in my equation. So that's going to be, and I'm going to put in 1 for y. So that's going to be 1 equals negative 2 times 0 plus 1. Then I'm going to say, well, that's going to be 1 equals negative 2 times 0 is 0 plus 1. Well, that's going to be 1 equals 1. On the line, yes or no? Yeah, that one's on there. So I can then plot this point 0 would be left and right nothing, up 1 puts me right there. Notice that I don't have a label for this point. I am just what is called plotting these points. Okay? I'm just going to plot those points now if they are on the line. They give me a true statement. Okay? 2, 5. So now I'm going to have 5 as my y value. Plugging it into this green equation. Two for my x value. Negative 2 times positive 2 is negative 4. Negative 4 plus 1 is negative 3. And is 5 equal to negative 3? No? No? So the direction said for points that are not on the line, because this point is not on the line, I need to cross them off the table. So I'm going to cross this one off of the table because that point is not on the line. Actually, tap the brakes. Let me go backwards just a little bit. Let's just cross the point off the table. We'll keep our work on the table. Okay. Negative 3, 7. So then we've got 7 equals negative 2 times negative 3, then plus 1. Seven is equal to negative 2 times negative 3 is positive 6. Positive 6 plus 1 is going to be 7. And 7 is equal to 7. So that one's on our line, yes? So we can plot that point. Negative 3, 7 would be 3 to the left. Up 7 puts me right there. Do I have enough to draw my line? Well, let's draw it. We're going to use something straight. We're going to use a straight edge. We're not going to draw it in freehand. We're going to use something straight, like a ruler or a ID or the edge of our folder or something, so we can draw it in nice and straight. spin that paper. Oh. 1, 1 is the next one. Well, visually, is 1, 1 going to be on our graph? What do you think, Tom? No, because it's right 1, up 1 isn't on my line, right? Okay. So algebraically, let's prove that then. So we've got 1 equals negative 2 times 1 plus 1. Negative 2 times 1 is negative 2, plus 1 is negative 1, and negative 1 does not equal positive 1. So therefore, that one is off of the grid, or off of our line, so that one gets crossed off. Three comma negative 5. Visually on our line or not? What do you think, Andy? Is it on our line or not? Because we graphed our line, so we could plot the point. That's one way to do it. Yay or nay? Yeah. Looks to me like it is. It's right 3, down 5. 1, 2, 3, 4, 5. Looks like that point right there. Okay. Algebraically, let's prove that. Negative 5 is equal to negative 2 times 3 plus 1. Negative 5 then would be equal to negative 6 plus 1, which is going to be okay. You find me another point that's on the line. Actually, you've already found a bunch of them. This was the same example as the front side. What was that? Negative 1, positive 2. Positive 3. Yep, negative 1, positive 3 would be on the line. Yes. Positive 1, comma, negative 1 would be on the line. And all those ones that are found on the front side. Okay? What I would like you to do now is I would like you to do number 3. So, of these 5 potential points, one of them doesn't work. One of these points is not like the other one. Negative 3 comma 7. So what would have to be there in order for it to be on our line? It would have to be a 4 there. Okay? This y column all has to be 4s. So when I graph this line, here actually tab break, let me plot some points here. So 0 comma 4 would be right here. 2 comma 4 would be right there. Negative 1 comma 4 would be right there. And 3 comma 4 would be right there. So when I graph those, I get that nice straight line. And that right there. Okay? This extra one, this last one that you had to fill in, the only thing, I don't care what number goes here, this number in that box could be anything, as long as all of those, all of yours should have a 4 in that one right there. Okay? When we plug in our points, I'll quickly plug them in. Because there's no x to plug in for. So there's only y's